Dear appreciated organizers and all participants, first of all, I would like to thank you for this great honor to participate in this famous conference. My name is Vera POPOVIC and I'm coming from Institute for Field and Vegetable Crops in Novi Sad, and today I will present you research work from my colleagues and me with the name PHACELIA honey productivity in relation to locality of cultivation. Around 250,000 plant species and about 752,000 insects described by biologists cover two-thirds well-known organisms on our planet. Most of plant species were pollinated by a number of insects, and if certain disorder appear in this relation, it could be disastrous for plants. Plant nectar has a big task in the life of plants. These tasks are to attract bees and other insects, which coming for nectar also transfer dust from one flower to another. The main contribution from bees lay in the fact that it could provide direct products which can be obtained from bees, such as producing honey, wax, propolis, royal jelly, pollen, and bee venom. Aside from this, the indirect benefit of bees is much greater, because bees are the major entomophones pollinators in nature. According to the official rule on honey quality, there exist 4 types of honey: single-flowered, multi-flowered, gingerbread, and baker's honey. The indirect benefit obtained by pollinating cultivated plants by bees is about 20 times greater than the products that these bees produce. About 80% of plants are pollinated by insects, and the participation of bees in pollinating these plants is huge. Bees also participate in the pollinating of fruits, vegetables, forage crops, with about 90%. According to Codex Alimentarius Commission Standardization, honey is the natural sweet substance produced by honeybees from the nectar of plants or from secretion of living parts of plants or excretion of plants sucking insects on the living parts of plants, which the bees collect, transform by combining with specific substance of their own, deposit, dehydrate, store, and leave in the honeycomb to ripen and mature. Honey exports contribute significantly to the agricultural economy of many developing nations. Besides the valuable nutritional and dietary value, honey presents one of the most successful therapeutic agents. Honey is the most antioxidant and also used in increasing resistance to diseases, strengthens health, prolongs life, supports the strength of mind and body. Dioscoride, a famous doctor who lived about 2000 years ago, wrote, "Yes, honey can be used successfully in disease of the womb, infected wounds, and fistulas." In addition, other bee products also show healing properties such as royal jelly, bee venom, and propolis. Broad honey production is estimated to 1,8 million tons in the year 2018. The largest honey production in the world, of about 46%, is produced in Asia, followed by Europe, America, Africa, and Oceania. China is one of the major exporters of the world. 10 biggest honey producer countries in the world, according to their production shares, are China, then followed by Turkey, Argentina, Iran, Ukraine, USA, India, Russia, Mexico, and Ethiopia. Honey is the major food reserve of Apis mellifera and the primary carbohydrate in the bee's diet. It is produced and stored in the honeycomb for consumption by the adult colony during period of nectar dearth. Honey is primarily a mixture of 2 monosaccharides, The majority of the sugars found in honey are fructose and glucose, which represent about 90% of its total sugars. Concentrated sugars account for 90 to 99% of honey's dry weight. Honey consists primarily of simple sugars, water, minerals, and nitrogenous compounds. Regarding to the pollen content, PHACELIA as rapeseed has been one of the second place with pollen amount with 60% of pollen grains. PHACELIA tenacetifolia is the most important honey-producing plant. Climate change, modern agriculture, impact of pesticides and other factors have reduced different types of nectar and pollen in growth, which affected the diet of bees. Honey plants, like PHACELIA, are of great importance for beekeeping. PHACELIA is successfully grown without the use of chemicals. It is interesting because of its long flowering, which makes it ornamental and honey plant. The PHACELIA crop is an excellent bee pasture. PHACELIA is an annual forage plant. It belongs to the family Hydrophyllaceae and it's originally from California and was brought to Europe at the beginning of the 19th century. It can be grown as a spring culture, winter culture, and as second crop. In our geographical area can be grown as a winter crop only if winters are mild. PHACELIA was brought to Europe as a honey plant, since it blooms 5 to 8 weeks, gives extended nectar, pollen is of excellent quality. Ornamental plant, fodder plant, it improves soil quality. Pedal hygiene, as a medical plant, used as a cover crop. It is also used to reduce Ambrose artemisifolia, protects soil from erosion, as for weed control. Based on honey production, all honey plant species are classified in 6 classes. First class involve plants where production of honey is up to 25 kg honey per hectare, while sixth class involve plants with honey production from 500 to 1,200 kg honey per hectare. PHACELIA belongs to sixth class. PHACELIA honey. The potential for honey yield varies from 500 to 1,200 kg per hectare. PHACELIA honey is light yellow with pleasant smell and taste. PHACELIA reduces Ambrosia artemisifolia. Almost 40% people from Europe has been faced with different levels of allergy to ragweed or have seasonal allergies. By the 2050, it is expected that climate change will cause double the number of allergic people in Europe to ragweed pollen, from the current 32 to 77 million. Along with introducing and spreading PHACELIA in our sowing areas, followed with good agriculture practice, ragweed could be reduced and therefore percent of allergic persons. Because of the great importance of California bluebell, the aim of this study was to examine the impact of growing localities on morphoproductive traits of variety PHACELIA NS priora and honey yield in Serbia. The aim of this study was to examine the quality parameter of PHACELIA variety NS priora produced during 2019 growing season in 2 localities. The first locality was in Novi Sad, while the second locality was in Zaječar. The experiment was conducted according to split pot design with 3 replication, with basic pot mounted from 10 square meters. The standard technology of crop cultivation was applied in both localities. Harvest was done at technological maturity of plants after 130 days. After harvest, morphologically productive parameters as a plant height and grain yield were estimated. The honey yields per hectare was estimated as its quality parameters. Quality parameters which are estimated are protein content, nitrogen content, oil content, cellulose content, and ash content. The success of California bluebell production depends from genotypes, applied technology, and meteorological data. Precipitation in 2019 on first locality were higher than long-term average, while average temperature was also higher than long-term average. Regarding the second locality, precipitation was also higher, while the average temperature was also higher than the long-term average. In general, based on this graph, we can say that in period from March to April, precipitation was higher in Novi Sad, while in period of May, June, and July, precipitation was higher on second locality in Zaječar and was 443 millimeters. Results and discussion. PHACELIA quality parameters. Average nitrogen content in both locality was 3,37 and varied from 3,4 to 3,35%. Location has no significant effect on these values. Higher values were achieved at second locality in Zaječar. Average protein content in both locality was 21,09% and varied from 21,25% to 20,93%. The locality had significant impact on these values. Higher values were achieved on second locality in Zaječar by 1,52% in relation to first site in Novi Sad. Average cellulose content in both localities was 4,35 and varied from 4,3 to 4,4%. The site had no significant impact on these values, and higher values of cellulose content were achieved on second locality in Zaječar by 0,100% in relation to Novi Sad. Average ash content in both locality was 21,14% and varied from 21,35 to 20,93% on first locality. The locality has significant impact on these values. Higher values were achieved at second locality by 0,42% in relation to first site. PHACELIA productivity parameters. The average plant height in both locality was 63,70 centimeters and varied from 57,3 centimeters to 69 centimeters on first locality. The locality has significant impact on these values, and at the locality in Novi Sad was observed higher values for plant height by 16,9% in relation to second locality in Zaječar. Regarding to seed yield, it was observed that locality has significant effect on PHACELIA seed yield. It was realized on locality in Novi Sad significantly higher yield in relation to locality in Zaječar. Average seed yield in both locality was 810,7 kg per hectare and varied from 761 to 860 kg per hectare. Locality in Novi Sad had higher seed yield by 11,47% compared to locality in Zaječar. PHACELIA honey yield. Significant effect on PHACELIA honey yield was observed on different locality. Average honey yield in both locality was 735 kilograms per hectare and varied from 663,3 on second locality to 806 kilograms per hectare on first locality. At first locality in Novi Sad, significantly higher honey yield was observed in relation to locality in Zaječar. larger and was higher for 70.8%. Flowering duration of Anas priora variety. Anas priora exposed high level of nectar content. Flowering duration of both locality was 55 days. With crop rotation with planting PHACELIA in 2 to 3 cycles, it can provide valuable stress for bees in long period. Flowers of PHACELIA possess high nectar content around 0.6 milligrams with sugar content of 20%. Conclusion. Variety Anas priora has been proved as a high-yielding variety with high nectar content. It has excellent seed quality. Average seed yield about 810 kg per hectare. High production of dry biomass from 7,200 kg per hectare. PHACELIA possess high potential for successful and high quality of honey production and over 800 kg honey per hectare. Significant influence on productivity of PHACELIA was observed on different locality. Climatic factors, temperature and precipitation, quantity and distribution had a great influence on PHACELIA productivity parameters. I would like to thank you for your attention, also to thank to all my colleges which were involved in this investigation, which was supported with 3 projects from Ministry of Education, Science and Technological Development of Republic of Serbia, and also 1 bilateral project between Montenegro and Serbia with the name Alternative Cereals and Oil Crops as a source of healthcare food and an important raw material for the production of biofuel.